Okay, Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Agus Kumaiti. In here, I would like to explain about my latest research with the title of Real-Time Detection of Mass and Distance in an Effort to Control Physical Distancing based on Faster RCNN. I came from Department of Marine Electrical Engineering, Politeknik Perkapalan Negeri Surabaya. Based on the governor rules of East Java, there are 2 points which explain about regulation of coronavirus disease in Indonesia. The first is point 1b explains that everyone is required to wear a mask and maintain a distance or physical distancing of at least 1 meter when outside the house. And point 2b explains that the person in charge of a restaurant or similar business is obliged to maintain a distance or physical distancing in a queue of at least 1 meter between customers. So that we separate the problems into two options. The first is how the system can detect people and objects using faster RCNN, and the second is how the system efficiently estimates the distance between objects using Euclidean distance. As the system planning, we start from reading webcam. So we have hardware. For the first is using a Logitech webcam that connected to the netbook, and then from the image reading, the process will continue to video processing process. After the video has been collected by the PC, then the object detection will start. This object detection will detect the object, in this research is a person, and then when the system detected a person, the process will continue to estimate the distance. And if the distance is safe, then the system planning will back again to estimate the distance. But if the distance is not safe, then the sound notification is on and the system is finished. For the hardware design, we put the camera at the corner of the room nearby the speaker. And for the software design, we have three steps. For the first is pre-processing, the second is training, and the last is testing. For the pre-processing stage, there are four main activities. The first activities is data set collections for RCNN, faster RCNN training activity. The second is labeling the image, and then the next step is convert XML to CSV, and the last for the pre-processing stages are convert CSV to TF record. At the training stages, we have four main activities. The first is pre-processing data, and the second is the main process called training, and the second is inference grab, and the last is exporting the model. For the last stages is testing with several conditions. And then for the distance calculation, we are using Euclidean distance. This Euclidean distance method are used to determine the distance between objects by determining the coordinates of the centroid value. For the data set of faster RCNN, we prepare the data with three classification or three classes. The first is mass, The second is people with no mass. And the third is people dataset. For the result of testing object detection, actually the detection is divided into three according to the predetermined class, namely mass, no mass, and people. Based on the test data in the table 1 from 140 data, the percentage of detection success was 92.67%. For the testing object tracking, we found that the system can perform object tracking in the form of objects IDs precisely according to the existing QE conditions. For the distance measurement, by using Euclidean distance, based on the test using 12 different distance data, the largest error is 1.86% with a distance difference of 0.93 centimeters. Here are the video of the Foster RCNN application. Once the user starts the system, then the software will start to capturing the image from the area. The first person we're not using a mesh, so the systems in here as we can see here, the system can successfully detect that the first person we're not using a mesh. Once the first person using this mesh, the system will detect the person successfully with the average percentage of prediction up to 100%. The same result also performed by the system when the second person were not using a mesh. When the second person's entering the blue area, the system will calculate the distance between the first person to the second person. As we can see here, if the distance is safe enough, then the notification will gone. For the conclusion of this research, first, based on the test error reaching 7.32 centimeters, the result from 140 data, the success of the system when classifying object in the form of mass, no mass, and people has an average success of 92.67% with a safe detection distance of 400 centimeters. And the second, based on the tests that have been carried out, the distance calculation using the Euclidean distance calculation produces an average error of 4.591%. This is the end of the slide. Thank you for the attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.